Hi everyone, my name is Kaushal. So today in this video I am going to discuss the Kubernetes deployments. I will create one application that I will deploy on the Kubernetes, and I will use the concepts like create, deployment, service, config map, secret, namespace, PBC, ingress. So I will explain each one concepts in detailed manner. Apart from that, I will show the demo, how to scaling the pods, how to rolling updates whenever our new feature is launched for our uh, application, then how I will do rolling updates on the pods. Apart from that, is something mishappenings during the deployment of any new updates, how to do it, rollback, and all these things I will explain with the help of Kind. Kind is a tool that will create the Kubernetes cluster locally on your laptop while running the Kubernetes nodes as a Docker container. Now comes to this projects. In this projects, this is a create folder. Here I have written all the YML files. Apart from that, this is my application, simple applications, and after that we have written a Docker file, and inside the readme.md I explain the steps how to run this application. So first of all, understand the flow of the application, what application is doing. For that I have created some images. With the help of images you can easily understand the flow of my application. So the flow is start from this src.app.py file and plus the Docker file. Here it will create this application as image here by using the Docker build. We define the name of the image is Kubernetes demo Python 1.00 this. Now after building this image, the next file that I have written here is namespace.yml. What it will do? Conceptually it will create a namespace. The name of that namespace is kube demo. So you can say it is just like a box. Here I will do for all the deployment, all other stuffs. So this is just a reserved area where I will do the further deployment in this namespace. After that, config map.yml. Here we will provide the all the user defined variables, and after that there is a secret.yml file. Here we provide the sensitive information that may be used inside the your applications. Now the uses of config.yml is, suppose you build applications and inside those application we have written some hard coded like where it will be deployed, like just you can say that deployment environment is dep. Now if you are going to update or you are just do on production, So you have to change the name from the dev to the production. So if we do in the main.py file, in those cases we have to rebuild the image again, and after then we upload it on the container and then move to productions. So in order to remove this headaches, so whatever user defined variable you can just define inside the config map.yml. So whenever you just change the name, just change inside the config.yml file, it will automatically reflect inside your main application. There is no need to make the image again. Now what is the secret.yml file? Here we preserve all the sensitive information like database, username, password, or different type of the password. So it will not expose inside the main applications. And if you want to change the username and password for the production, it can easily be handled here without changing the image also. Now comes to the next file is the pvc yml. Why I will use this file? Actually this file is used to ask the Kubernetes for persistent storage for your application. Suppose if you want to write something inside your code inside a database, and that data will store where it will store. It will store some persistent location, because if it is if we write down that code inside the code and we does not preserve the persistent states, so whenever the pod destroy or container destroy, your data may be vanished. So in order to uh, overcome this situation, we use the pvc.yml file. Here whatever the readout information, it will return the location provided by this yml file. Now next one is the deployment yml file. So in this file we have to define the how many pods you want, different type of deployment configurations. And next is the service.yml file. It provides the upon it provides a port number where all the ports are mapping. Suppose there are many ports. These ports have different IPs. So if you want to communicate to the ports and port is destroyed, then IP also vanishes, because next time new port will be created and the IP of that port may be different. So in order to achieve this in order to overcome this difficulty, we provide us one service endpoint where all the ports are communicated with the label name, not the IP address. And this service.yml is exposed to the outer world, where from where the you can communicate to different ports. Now comes to the ingress.yml file. So what will be the use of ingress.yml file? Suppose in production mode you have different type of the services, like so what actually it will contain? Actually, it will handle outside HTTP traffic that will reach to the suitable applications. Suppose if you have a different applications, different nodes, means in one node something, if you hit one URL http:/example.com, it may contains the different routes slash services slash slash some production mode services. So that can be handled by the ingress.yml file, and in detail I will explain in further by the diagram, and this is the exposed by the outer world. So which file is when? It will gives the namespace.yml, config.yml. So these scripts manifest in dependency order and wait for the rollout state. Runtime request is what? Whenever you hit from the browser, it go to the ingress. Ingress will go to the service endpoint, and after that it will go to container port, and container port will go to your Python application which is running inside in the form of images also. So all this flow requires these files like config.py file. From here it will read the different environment file that you have set, and from secret here, so here from here it is also read the some secret information like database username, password, or etc, something like that. And after that it also read the pod name and pod namespace from here, and from PVC it will mount the all the persistent data stores point, and from image it will read the app version. So now you can use the Kubernetes with the help of Minikube, and there is another option called a Docker desktop. From there you can also Kubernetes, you can enable the Kubernetes, and you can also use the kind. As I already told you, kind is a tool that will provide the Kubernetes cluster inside your Docker. So here in this my example I have used the kind. I will show the demo. So namespace isolate the resources. Config mag, what it will do? It will contain the no secret configurations information. Secret will contain the sensitive config information. Persistent storage PVC. Deployment manage the ports and any updates. Services stable internal endpoint. Ingress external HTTP routes. Now comes to the second image. One second. Yes. Now these are the different tax descriptions which we have written inside the YML file. Like inside the name.yml file, this will show the core API group, namespace, create a logical boundary, metadata, identifying the information. Name cube demo means namespace name used by all other namespace resources. Label app Kubernetes part of Kuberdemo. Describe the project label. So this is apply the first. Other manifest depend upon on this namespace.yml file. Now comes to the config.yml file. In this file, now this is the kind config file. This is a kind namespace file. This is kind secret, kind persistent volume, kind deployment. So the type of the YML is defined by the this variable name the kind. So here this is the kind config means non-secret key value configurations. Meta name demo app config, the name of this one, where it will run cube demo. Inside this namespace, what it will contains app title, Kubernetes field notes. App message, this message comes from the config.map without rebuilding the image. So this will show the runtime message text, page heading, environment variables apply to the app, जो app को supply होगा, and meta name is stored inside the cube demo. Now comes to the next YML file. This is the secret.yml file. Kind is secret means sensitive config objects. Meta name demo app secret. Namespace cube demo. Type is opaque. Opaque means generic key value secret pair. String data human readable input. API convert it into data. Support email, this is the key value pair. Deployment, read this via the in emp file.config. I will show in the deployment.yml file, and deployment reads this by this environment.from config map. Now comes to the pvc.yml file. Kind is persistent volume chain. Ask for the persistence, storage, access mode. Read write once means mount read write by one node. Resource request storage 100 MB requested the capacity. Deployment mount this claim at this label /data to keep the widget.log. All the information of the mounting comes inside the widget.log. Now this is the deployment.yml file. App version kind is deployment, metadata, name demo app, namespace is this, label demo app Kubernetes IODEM. Now specification, replica, how many pod will it will create. Revision history is 5. What does it mean? Keep 5 old revision for the rollback. Now next is strategy, this rolling update. What does it contains? Update the ports gradually. Maximum unavailable, don't reduce the healthy pod during the updates. And maximum search, create one extra pod during the update. Suppose we have defined the limit replica is equal to 2. So during the rollback, it can create only one extra pod. So whenever that pod is ready, it will automatically update and on the this and destroy. Now selector match level means deployment find its pod by this level. Deployment by doing the deployment, how it will find out the which pod it has to create it 2 or 3. It is defined by the selector tag match level. The name of the pod will be the demo dash app, and next is the template, which is the blueprint of the pod. Now template.meta.label copies into the onto the pods. So deployment chain will be the namespace, it will go config.ml plus secret.ml plus bbc. All this information is ready during the deployment. Now deployment, advanced control, proofs, resource, volume, security tag, etc. continues slide 3. Now comes to the slide number 3, where I have defined the next tags. Now inside the deployment environment, advanced tag is this security context. Number one is the template specification security context. FS group 100. Shared file ownership for mounted volume. This is ownership. Now image policy, if not present, reuse the local image if available. Here. Now port name, HTTP and container port is 1000. Named app port name is HTTP and container name is 3000. Environment from the config. So for configuration, this is the name and port, and environment coming from the config reference. So it is reading by the config.yml file. Name is this, and secret information, secret reference name is this. What does it means? Environment config reference plus secret reference. This is secret reference coming from the secret reference, and this is coming from the config.yml file. So these environment value is coming from these two files. Now environment value coming from the field reference. Download the API for the port name and space. Field reference. So this is coming from the port namespace which we have defined inside a deployment.yml file, and reference is also coming from the deployment.yml file. See here, I will explain. The local variable name, from where it is coming, metadata dot namespace. This is the name here, right? So this local value is coming from the which tag? Field reference. Now comes to the data directory / data value. Name is data directory and value is / data. So application storage path. Now volume mount the PVC inside the container. Mount the PVC inside the data directory is coming from where? I think pvc.yml file. Data directory. From where it is coming? What name? Data directory volume mount is this, mount path is this. So mount the PVC inside this container. So in this location pvc.yml has been mounted. Readiness proof, when the service may send the traffic, and liveliness proof, whether the kubelet should restart the broken container. Readiness whenever it is ready for the services, and liveliness, it will check whether the pod is running or not. If some pod is deleted, so it will compare from this replica value. If some pod is destroyed, it may automatically be recreated that pod. Now resource property, minimum CPU and resources. Minimum CPU, what it is required, limit is maximum it can be used for any pod creation for one node. Now comes to the service.yml file. Here kind is service, established virtual endpoint for the pod. Type is cluster IP, means internal cluster access. Selector, choose the pod with the matching label. How it will select it? With this name. Now port, service port that client can use, and target port means forward to the named container port name 3000. So the service port name is 8000 and it is forwarded to the pod 3000. Now comes to the ingress.yml. Okay, so kind is ingress. HTTP routing rules. Ingress class, what it will be? It will use the nginx controller, and these are the rules. One list of the routing rules. Host, this is just like a DNS name, like www.abc.com, where it will go whenever we provide slash path, and for the backend services is running where it is in this port number. And in the same manner, suppose in the production environment we have the backend, we have the front end, we have our database. All these may run on the different nodes. So in order to communicate all these nodes, we use the ingress.yml. We can also do directly, but we have to use the three services, three fast. Now if we want to map to only one IP like www.abc, let me explain here. Now these are the services. This is the back end and front end node. Suppose some database node. Now if we don't use the ingress controller, we have to define the different like www.abc abc slash back end in the same manner www.avc/front end, and in the same manner www.avc/database. So here we have to define the three endpoints. Now if we use the ingress controller, it can be easily just by www.avc, and if we use the ingress controller, ingress controller, now it automatically handles all these endpoints. Which type of services you want, it automatically be route to corresponding backend. So whenever we slash backend, it decides where the backend is running. It is running on this IP, and if we do slash the services, ingress controller know on which IP this container is running, on which node it is running, it will automatically go to that node. So different type of the services को decide करने के लिए we have to the increase controller from the external traffic to different type of services. This is act like a middleware. Now comes to the next concept. So this is this ingress controller. We use the nginx. Rule is this, path is this. So whenever there is backend is provided, it automatically gives to the this endpoint. So path is root product, path prefix match this path and subpath. Backend services name demo port 80 send traffic to this service. So ingress needs a running nginx inject controller. So this is the file where we have to define all the rules, but in order to execute the ingress, we need the ingress controller. So now we can verify the deployment with this help of all these things. For this I will show the demo. Now comes to the next slide. Here I will show the how it is following the architecture. Suppose we have kind. So first of all, whenever the browser will use this one, and that entry is defined inside my local, I will put this configuration inside the etc.host. Now it will comes to the MAC host IP this one. Now export mapping 82.82.443.2 means this mapping is defined inside the kind demo.yml file, and inside the kind demo file we have one control panel, name is ingress ready. Now it is ready to handle the ingress controller. So the namespace of ingress ingress this, read the host header path and fix the backend layer 7. So on port is 83 and 440 the single entry point. Now in whatever rule we have defined inside the ingress rule, we have defined this, that it will go inside the Kubernetes namespace. Here we define the service demo endpoint, and after services it go the corresponding pods, and pod will reads all the information from the config and secret, and all the persistent will persistent data will be stored by reading this file, and the name of the pod is be defined by the deployment.pyml file. Now comes to the next roles and creation flow. So role of each one, namespace is it is created to the isolate project resources. After the config map, it will stores the non-secret app configuration. Secret, it will contain the sensitive information. It requires the persistent storage for visit.log. Deployment, manage the desired states, replica, rolling update, rollbacks, and self-healing. It is created by deployment.yml file by kubectl apply, and replica set maintains the correct number of the pod replicas. It is created automatically by the deployment.yml file. Pods runs the containerized Python app, and it is created by the replica set from the deployment template. Services provide a stable internal endpoint. Here we are used 80 for the pods. So all pods are associated with this service endpoint where 80 is there. So it is created by service.yml file. Now ingress, it defines the host path routing for kubedemo.local. It is created by ingress.yml file. Now ingress controller, actual software that reads the ingress rules and routes the traffic. How it is created? It is installed separately. For example, nginx ingress controller or miniq add-on enable the ingress. So in my example, I use the nginx ingress controller. After that, it is contain the container which contain our application logic. So a role is actual application role running on the 3000. So this is created by the docker build from the docker file. Who create whom? Now this image is created by the docker build, and that image is going inside the deployment.yml file. It will create the replica set, it will create the pods, and the information for the pods are coming for the config.yml file, namespace, and where it will create it is coming from the namespace.yml file, and all the secret and config information is coming from this here, and your data your persistent storage mounting is provided by this file. After this, pvc mounting add data slash data and config and secret injected environment variable here, and next is downloaded API value available in the pod name, pod space. After that, it will running on this service port, and that service port communicate to the ingress dot by ingress, and that ingress is created by this ingress controller. It handle the external traffic and apply the nginx rule. Nginx rules is defined here. So this is the networking and traffic flow, and this is the orchestrating staging means controller, and after this browser endpoint. How to create each one in this docker to build the image, Docker build, and name is a config. We use to kubectl apply minus s corresponding YML files. And so this is the difference. This is the roles and creation flow of the my application. Now comes to the port flow, how it is flowing from the client to here. Suppose we hit from my MAC address like this 127.this in local. Now browser entry point 80 or 443, desktop browser URL kubectl localm and localhost. Now this is the host port 8044p and we map to the our node controller to 804443. So host port on your desktop and node container port exposed by the kind export port mapping. This is the kind control panel. Understand, this is not a actual container which contains the our logic. This is the kind that we are using for creating the Kubernetes. After that, it will mapping to the ingress nginx controller. So nginx controller listen on ATL 443. So ingress port where the ingress controller receives the HTTP or HTTPS request. Next one is ingress resource file. Route based on the host and path to the backend services. Next one is the Kubernetes service endpoint. So stable cluster facing cluster. After that it will communicate to the service endpoint which is running on 80, and after this target service forwarding traffic to the this port name, and it will forward to the corresponding pod, and pod is running on the 3000 ports. So from the client is mapping to the kind controller. Kind is a software which runs the Kubernetes inside the Docker container, and this is mapping to the nginx controller. Nginx controller is the rules, and after reading the rules, it forwarded your request to corresponding services. Suppose your backend is running on 80, your front end is running on 100, and so whenever you want to want the front end endpoints, so it will automatically convert your traffic to the front end port number 80, and from that service endpoint it will go to the corresponding port which is uh, identified by the your port name, and inside that port name there is a container port where our the actual logic is running. These are the command to run the first we create the cluster, then we apply the nginx, then we apply the different YML files, and after that we can verify with this help of the pods, ingress and health checkups. So kind run the Kubernetes nodes as a Docker container. Export mapping connect the host port to the node container, and ingress routing this traffic to the services, and services forward to the port container 3000. So this is the overall flow of the application from port point of view. Now comes to our inside the code. So whatever I have done, all this is defined inside these files. You can read and hope you can understand which I have provided by the demo. And this is a kind demo, this one here from where we created the cluster now, and this is the just a small application to show your demo, and this is the Docker file. How to create the demo, how to create the Docker, install the Python image. Inside this one we create this folder, and if copy all the app inside this folder, expose on the 3000 port, check the health checkup, and use the command src.py file. It will create that, execute the logic. Now inside the readme file I have written all the steps to execute this program. Now I am going to run the demo step by step manually. Now first of all create a cluster. You can see inside our Docker nothing is available, no container, no image. Now first of all I will create the cluster. So it will create by reading this kind demo.yml file. Logic is here. It will create the control panel and mapping the 80 port host port protocols. So it will available on 80 port. From this host port means for my machine will use the TCP, and it also available on 443. Host port is 43 and TCP. So it will create the demo. So how it is created? It is creating the cluster, this one, ensuring the node image. So it will downloaded this image kind as not this one. As I already told you, kind is a software. It is downloading that kind inside our the Docker, and it will create the node, writing the configuration, starting the control panel. You can see here image is downloaded. Now it is creating the container. Now this container is running. That means that our Kubernetes cluster is created now. Now I can use all the Kubernetes command from here. Next, now as I already to publish the nodes Mac 2443, and without this has nothing to connect to this ready notification. Now I will verify whether our correct context is ready or not. Yes, it is now ready, and all the conditions is available. Keep wait for condition ready. Timeout is this one. So all the control panel condition is met. Now you can find out the nodes. Nodes means machine. Yes, name is this, status ready, role इसका ये है, एज इतनी है, वर्जन है. Now run the test, build the image, load into this. So I coming directly inside. First of all I will create the Docker image. The name of this I have given the Kubernetes demo Python. You can see here there is no image for this like Cooper Python demo. Now it created the image and load inside the Docker. Yes, Kubernetes demo Python image is ready now. Now I will load this image inside the cluster that we have defined. Kindly load. Now our image is come inside the Kubernetes. Now you can verify here Docker image Kubernetes. This image available. Docker execute. Now install the NGINS controller. I already told you, just defining the uh, only this file, it does not work. We have to install the NGINX. So this apply -x http this example this deploy NGINX by YAML file. So we download this NGINX controller. Now you can see here antenna is ready and the this NGINX is available here. NGINX con. Now how can I check whether NGINX is installed or not? Yes, you can see here kubectl NGINX class is registered or not. Yes, you can see here inside our container this is registered. Is the controller pod is running? You can check here that corresponding pod is running or not. Yes, it is running. One is ready, another is running. Now kubectl is the service presented. Yes, it is presented here. Load balance and a cluster IP. Does the name space exist in Grace and JNX? Yes, this namespace also. So NGINX is installed for the ingress controller. Now class NGINX must match the space class name NGINX in this one. If they differ, ingress is sanity, no error will be available. Now I am going to apply all the YML file. So everyone is created now. And you want to see what is the status of deployment of app successfully rolled out. What does it mean? Our image is now inside the container of Kubernetes. Just go here. Now you can do one by one. I have already done. all the YML file. Now show everything that was created. Now you can see that the get all PVC config secret image inside this namespace. Yes, everything is sub-level here. Host retrieve and verify. Ingress matches the host Kubernetes demo, so browser must send the access the host. So your Mac need to resolve the name is this thing. So you can do here. So this is the steps to put this entry inside the etc file. Now you click on this one. Yes, you can say here. Now this domain and our client IP 127.0.0 our port is mapping. Now from here there is a nginx controller, it will control and divert to my machine. So this is the use of nginx control. I will show the demo here and it is working now. Now stop and fix, continue with these, don't match. These are the command to find out whether everything is working or not. Now next go. Now port is told its own identity by Kubernetes, not by the image. Now Kubernetes execute code demo deploy.depot environment get port name. So these are the port name and there is two ports which are created inside the Kubernetes. Why it is showing the bad request you already know, because it is now coming from the nginx. Now comes to the scaling and load balancing. Now I will create the scale up the up to 4 replicas. CTL. Now you can see the status whether the application has been completed inside the new pod or not. Successfully rolled out, and you can see the pod will be the now 4, 1 2 3 and 4. These are the 4 IPs of the pod. Now again we down, we do the now for 2 pods will be running. Scale down, you can see it is going to terminate it. 2 and 2 is running. After some time it will show only the 2. Terminating. Only 2 is running now, and now I will show the demo of the self healing. Means if any pod is deleted for any region, it automatically create the new pod. You can see here there are 2 pods running. Now comes to the second screen. Cube delete this appy field register is running. Only it will, here I will delete the pod. Now you can check here. Now all will be deleted, only 2 will be available now. So replica set creating the replacement within second. You never ask to it deployment to declare the 2. Now I will show the error. What error is coming? 1 second. Happens. Yes, 2 is running now. Now I have created the new image for the new version. So now second image is created. Yes, for version 2.0. Now second image is created. Now how I will roll out to Kubernetes by using this command, and you see how it is doing. Just execute this command and see the changes here. What happens? Yes. Now within second the new version is available right now. This is version 1.0. Again refresh. Why it is not updated? What happens? It show the 2.0. Okay. Now that image is loaded inside the Kubernetes. Now I am going to set the image. Now it will show the Python 2.0 version. Okay. Image has been updated. Now you can see it is going, it is created one more, and it is doing updating the image. First it will create the new pod. When it is rating, it will terminate one and create again the new pod with this new image. And you can see the status here, what is going on by this command. Rollout has been completed, and you can see the history here. with this command. Revision changes clause none, and I think it will show the screen now 2.01. Yes, now our new updates are updated inside the Kubernetes on all the pods. Now I want to roll back to the last version that we have done. Yes, you can do by using the undo command. Roll out undo. Now you can check the status here. Waiting. It is now doing the updation. Now it is successfully. Now again it will show here the 1.00. Yes, we successfully roll back the changes to old image. Now next demo is for showing the persistent volume survive everywhere or not. So note the PVC visit the counter on this page. The counter lives in the data slash visit dot on PVC, not on the container. Now first of all I execute this command. Everything is available. Volume of persistent something, and now execute this Kubernetes demo deploy slash demo deb. Yes, this is available inside this one. Now I am deleting the pods, all the pods here. Now this is deleted from this one. Now check the status of this. Has been deleted. Now again I will find out the yes file. Yes, this is available because I have used the pvc.yml which stores our data inside this widget logs. Now props and security concerns. Now describe the demo. kubectl. This is now describe the pod and manage a Kubernetes seed events.py file. What is this? Successfully assigned this one. Container already present. Container created this one. Now application logs. You can do it. You can find out with this one. Now container runs as not used with all the capability dropped. What does it doing? This is also new for me. So that's it for the this video. I have provided a lot of information. Hope you people like it, and I have tried my level best. And thank you for watching my video. See you in the next video. Till then, keep learning, keep hustling. Have a good day. Bye.